Hello everyone. So here I have created a definition in Grasshopper that automatically creates a half-lap connection between CLT elements, in this case two walls that we're seeing here. And half-lap connection, I mean this sort of arrangement on the top view. And this is a typical type of connection between CLT walls and slabs. So the Grasshopper definition is very basic. It's just a bit of an experimentation, thinking about how we go ahead and model things. So normally what you would do is you would have a wall, and then you'd split the wall into separate little pieces, and then you would apply a half-lap tool to that split. But in this case, this definition that I've created, I've been thinking more about components. So looking at the standard types of sizes of elements. So in this case, for example, here I have a panel width. In this case is on the x-axis, as this is going to be part of a larger CLT box design. We'll have it on the y, and we'll also have a slab. So the panel width, what I refer to here as panel width is 1000, 2500, 2730, 2950, and these can just be whatever sort of standard sizes that are that the manufacturer is using, and it will depend on who you use. These are based off of KLH standard sizes, not the 1000. That's just easier to visualize. So the approach here is thinking about standard widths and having the half lap already applied to them, and then generating a wall or a length of element using standard widths. So thinking more about the optimization of elements, as opposed to just creating a long wall of X amount, but having a little bit of a leftover at the end. So in this case, it's as you'll see now, it adds a new panel width as we increase it. But let me show you what I mean. So basic 2 panels here, and then we can modify the panel width. So let's say we want to use 2.5, so it's just working. You can't draw a straight long line here. It's only working off of standard widths. And kind of the idea behind the standard widths here is that this will fit into a larger mother panel with little to no wastage. Of course, you have the wastage from the half lap, but looking at more sort of the optimization of things. So here we have the same type of idea, but with panel thicknesses. So if I look here, a list of random thicknesses down to 80. You can see here it's just a bit smaller. And of course, as you change this, changes different thicknesses. And height, so sort of automatically generating heights. Nothing super intuitive here. And then this is, I suppose, the most interesting part of this is the generating new standard width elements along an edge. So for example, here we've got 2 components, and if I start to increase this, see it starts to automatically add a new panel of that width. So if I change that back to 2.5, you see it goes smaller. Back to 1000, gets smaller again. So this is just adding new panels along a length. And that's thinking about the component sizes here. So that line from there to there is, in this case, the way I have to set it up is always going to be 1000. And that's the optimized size that would get cut out of a nested mother panel. And so if we look at this concept and we say the half lap width here, which is adjustable, at the moment it's 90 millimeters, we make it smaller. You can see here that actually the wall length is increasing. But if we go the opposite way, we start to make it larger, you can see the wall length is starting to reduce. And this is because you're effectively cutting into the adjacent panels. And this is a type of cost, a volume or meter squared cost that might not be initially appreciated, but it definitely has an impact on pricing and costing of CLT elements, and obviously machining. You wouldn't really cut this big type of lap. So that's the little basic concept that I've knocked up for now. Just a bit of an experimentation, really, thinking about the connection between elements and how can we automatically generate them. Nothing too elaborate here. I will continue to add a Y direction and another X, and then so you kind of automatically generate a box with a slab on top as well, and just a super simple box idea based on standard widths of elements. So let me just make this super big here and have a bit of a play around quickly. And a little look at the definition. So this is just for one edge on the X. Great, that's all for now.